So before we start, I'm going to take the attendance. So all are going to check. Aman, raise your hands. Okay, next, Tanya. The screen is visible to everyone. All are going to raise your hand during your turn. Khushpreet Kaur, right? Khushpreet Kaur, Anchal.
Excuse me, sir.
Yes, Anchal.
Sir, this is Kirabdi Tanaya. Sir, I am present, but
Okay,
I am unable to raise my hand.
okay, fine. After that, after your attendance, just lower your hands. Anchal, done. Shalini, Anchal, your attendance is done. Harshdeep Kaur, during your turn only, raise your hands. Akshita, Suraj, Harshdeep Kaur, Akshita, Suraj done. Gracie Markan, Shivam, Itish, Ajit Rawat, Itish done. Shivam, Gracie Markan done. Ajit, Soumya, Shidhanshu, Manpreet Kaur. Okay, fine. Mubashri done. Akshat Tiwari, Deep Kuvar, Vishwajit. Okay, fine. Anyone left, just raise your hand so I can, otherwise I am going to mark your attendance. And nobody will leave the session during the lecture, right? Otherwise I have to do rectification and I will I just mark the attendance. Okay, fine. Later on I marked. So today we are going to discuss a first topic of this design and analysis of algorithm. It's a very interesting subject and one of the easiest and one of the good subject. So many things you can learn in this subject, right? Now screen is fine. So what is the main concept of this subject? First, we are going to understand what is design of algorithm, how we can analyze any algorithm. What is the difference between this? So the difference between this is that whenever we have any algorithm is like your name who joined just.
Sir, it's Shalini.
Okay, I have not marked yet, right? That's why I stopped here, right? Don't worry. So next time be on time and so first we are going to discuss what is designing of algorithm. Designing of algorithm is basically a layman language we can use. We can follow any structure. We need to write any algorithm in the form of English sentences, right? Let's suppose if we want to calculate factorial, right? How we can, what steps we need to follow? The screen is visible to everyone, the factorial text box is visible to everyone.
सर आपकी वॉइस में दिक्कत आ रही है.
अभी ठीक है?
सर ऐसे तो ठीक है बट अभी जो आपने
Sometimes
इससे
आ
पहले
रही है.
जितना भी बोला वो नहीं सुना.
Okay. Today we are going to discuss designing of algorithm and how we can analyze that algorithm. What is the basic difference between this? Because this subject is very important, right? And we can learn so many new things in this, right? So let's suppose if we want to design any algorithm, example I am going to take, that is factorial. What is the basic step we are going to follow? First we are going to take input. Take any input, right? Take any input. Let's suppose that is a, right? This text box is visible to everyone, factorial.
Yes sir.
Okay, So next step is that we need to calculate factorial. We need to add one loop. Any loop we can use while a is greater than 0. Right? This is the condition we need to follow. Let's suppose our value is 5. If I want to calculate 5 factorial, then 5, 4, 3, 2, and 1. Right? This is the process I need to follow. So that's why I will take here while loop or any loop we can use. Right? In this, inside this, we need to multiply. Right? So here we can take one variable, let's suppose fact. So this is a general procedure to write any algorithm. Right? Fact. I'm writing here because I want to tell you the like analysis part, how we can analyze. That's why I'm going to write this. Then a, then each time we need to decrement a. Right? So this process executes up to how many times? 5 times according to the value of a. If a is 5, then it executes 5. If a is n, then this output executes up to how many times this loop executes? N times. Right? If the value of a is n. Right? 5, 4, 3, 2, 1. Right? Because greater than 0. So designing of algorithm is this. We are going to design algorithm. We can write any algorithm. We can execute any program with the help of our any programming compiler, any, right? But analysis part we can analyze. We have to understand that code. How much time compiler will take to execute this first step? Let's suppose 1 second. Right? Next, if the loop is executing 5 times, so what we need to write here, the value of n is 5. If the loop is value of a is n, so it is going to execute n times. So the maximum complexity is that we are going to understand that here the system is going to execute n times. Right? So in this way we can analyze the time complexity. Another one is space complexity. How much space we are going to use in this? The major two things are major. The first one is time complexity. Another one is space. Right? So many other things are like bandwidth, frequency, tolerance, right? But that can be easily maintained with the help of upgraded systems. Let's suppose if I am running in i5 processor, right? There are two things in this time complexity. One is priority based, another is posterior, right? In first type, posterior is like we are going to execute optimal value like approximate value, right? Like of in that number of that can be handled by our upgraded systems. But priority, like we are going to fixing our inputs. Like let's suppose this is going to execute 1 second and this whole condition up to execute n times, right? According to this condition, this loop, right? In this way we can understand. But let's suppose frequency, bandwidth, let's suppose our system is going to, our application is at in our hosted at our web hosting part, right? So how much bandwidth it is going to take, consume while we are going to reload our page, loading our page. That is another parameter. We are not focusing on that thing, only time complexity and space complexity we are going to focus on that, right? Space is like how much space it is going to take. Let's suppose this is a variable, right? This a variable is going to store, take 4 bytes of memory in C or C++, right? And again, factorial is also part of integer. 4 bytes of memory it is also taking. So total how much memory it is going to take? 8 bytes. Roughly, if I'm talking about 8 bytes. Rest things are going to understand by how much time, complete time is going to take. That is done by some compilers. Sometimes you can check the compilers, like upgraded compilers. Let's suppose 1 second it takes to execute whole program, right? Sometimes 0.5 seconds it going to take, right? It depend upon the system's configuration. Clear? So main agenda is clear to everyone. Raise your hand if anyone has any doubt, any query till now. So now algorithm is basically a step-by-step approach. So it's a step-by-step of completing a task. What is computer algorithm? A set of steps to accomplish or completing a task, right? With the help of computer, we are going to execute. Some other algorithms, yesterday I also discussed, like a GPS. Here we have an algorithm with the help of GPS system. Can anyone know the full form of this GPS? Yes, students, anyone? Yes, global positioning of a system, right? So here GPS is we have different routes, we have different algorithms are like, initially we have a one GPS system, like which is going to track a single map, which is mostly used, single path, which is mostly used by the persons. That may be a shortest path, that may be a like a fastest route, right? Now in GPS, now we are having feature, we can select that options, right? Now we have a recently, we have updated version of GPS in which we can calculate our toll tax, like in which road, if we are choosing this, how many tolls we have to give. All the things are mentioned, right? Initially, let's suppose Google Hangout. What's how Google Hangout is going to work? Like a WhatsApp. In GPS, we are going to use shortest path algorithm, right? Previously, but now we have a shortest, fastest, like less traffic path, any path we can choose. Now in online shoppings, we have some algorithms like cryptography algorithms are like RSA, right? So we have some inputs. We are going to give some inputs in the form of like any criteria, yes, no, like any value we can take, right? According to that inputs, our outputs are going to work. So here we have some correctness. Let's suppose we have algorithm must be basically providing a correct result must be right. We can test our algorithm using some testing, unit testing, okay, right? So here we have one more term about time taken by the algorithm. We have two ways. The first way is the performance measurement, or we can say posterior analysis, right? We already, another one is performance evaluation, that is prior analysis, right? Here in this we are going to implement the algorithm in which machine, and then in machine, and then calculating the time taken by the system to execute the program successfully. That can be a, this posterior can be done by the system. This is going to depend on the configuration of the system. And but in prior analysis, before implementing algorithm, we have to follow some steps. What steps we are going to follow? Let me show you how we can do. How long the algorithm may takes. We are going to check the functional of the size of the input, right? Let's suppose fn is the function, how much take it, this take, size is n, right? So in this way we can calculate. Now rate of growth of the running time, clear? The basic concept is clear to everyone? Till now anyone has any doubt, any query? Yes students, till now anyone has any doubt, any query? If it is clear to everyone, just raise your hands. Okay, fine. Lower your hands now. Now understand this. Algorithms are just like a technology. I'm going to read this statement so you can understand. We all use latest and greatest processor, but we need to run implementation of good algorithm, right? While we are going to execute any algorithm, there are three things: the best case, average case, and the worst. A worst time, what it takes, average time, what it takes, and the best time, it what it takes, right? Let's suppose we are going to execute any, we have here, we spend to have latest processor. Let's take one example. This one faster computer A, right? Running a sorting algorithm. We have one sorting algorithm, right? And another one is like again, and two again slower computer, means we have two systems. One is A system, another one is B, right? If we are going to use posterior, right? Then there are the time, how much time, there's a time difference is going to occur, right? But if we are going to use second system, prior analysis system, the time is same, because we are going to fix some values. We are going to check how much inputs we are going to use. Let's suppose we are going to perform a sorting algorithm that will grow like n log n. This is the complexity part, right? The sorting algorithm is like a sorting of array, 10 million numbers, right? A computer A executes 10 billion instructions per second, while a computer B takes 1,000 times faster than computer B. It means if B computer executes 10 million, the faster computer will take 10 billions, 1,000 times faster than, so approximately automatically output is different. Clear? So in this way, this is just a small part of this course. Right here, you all can see here, have your n square like 2n square is the instructions, 10 billion instructions per second. Here 10 million. So in this way we can calculate. So we can easily calculate the time taken by this system. We are going to perform some concept, right? Log and we need to solve, then we can easily calculate. So this is a basic understanding of how we can solve any algorithm. Some more details I am going to discuss here. Let's suppose we have an algorithm. Let's suppose I'm going to execute a few more things. Let's suppose n square plus n. Here I am going to write 2 into. We are going to discuss all these things. Fn function, here is Cn. First of all, let's suppose any equation we have a, what type of equation we have this? It's a linear equation, quadratic, polynomial. Yes. And how we can write how we can analyze this thing? Let's suppose this n, right? We are going to take every time according to this graph, what we have, Cn is greater than Fn, right? If we are going to assuming this thing, Cn is like a constant. C means constant. How much time this whole equation is going to take? We are not exactly writing here equals to. We are going to write here greater than equals. right? At what, how much time this execution is going to happen? What I will write here on the right side, like this becomes, the first equation becomes greater than or equals to. What is the best case? What is the worst case we can say? Or what is the average one? How we can understand? Let's suppose I am going to take, if I am going to take here n, right? If I am going to take here n means this equation n is going to take, I'm going to talking about complexity, how we can check the complexity. If we have a multiple things inside our for loop, now this is going to execute up to n square. If I'm going to take, always this is left side is always going to take larger value, right? But how we can check this equation is going to execute how many times? We need to write here that value which is going to tell us, like after that condition, this condition is going to change. Sorry, less than, I need to write here less than or equals to. Let's suppose if I am going to check n, this let's suppose value of n is 1. Here we have 1, here we have 2 plus 1 3. Right? So this is a valid condition? No. Next, the value of 2 and 2, we can take n value 2. Again, this n is not possible. This never be equals to that condition, right? So we need to assume that first thing we need to take the maximum value, the maximum time taken by this expression n square. So we can easily check this thing, n square. Then cn, this is the function. Now cn we need to write what constant value we will write here that will break this condition. That becomes the, that going to reverse the condition. Let's suppose here is 2. Let's suppose if I'm going to write here 3, what happened? And value of n is 5. So 25 into 3, that becomes 75. And now here
Sir, you are not audible.
okay, now my voice is audible. So
Yes.
this becomes 25 into 2 50, right? Here becomes 55. So we need to write that, we need to choose that constant value which is after that this expression is going to becomes a valid expression, means always greater than equals to this. We need to choose that value, right? So this is a very general example, like how we can check the any expression, how we can check the complexity, how many times this is going to execute, All these things are going to coming under this concept analysis part of the algorithm. Clear? So we need that in this way we can check which one is the worst case of the algorithm, which one is the average. Worst case we can say big O notations, big O, right? That is we are going to discuss in very detail big O. Another one is omega, last one is theta. We have three notations, more than three. We have little big O, little omega, right? In same way we have, so basic we have three. Clear? We are going to discuss in next session. Clear? If anyone has any doubt, any query till now, you can ask any query.
Sir, how can we access these recordings?
Okay, these recordings I have to upload all the recordings, right? I'm going to upload. Even I will ask to the team managers, like if we have a provision on LMS or not, right?
And sir, please share the PPT too.
Yeah, sure, definitely I will share. I will create one Google Drive where I am going to putting each and every PPT step